All right, well, good morning and happy Monday. Wait a second, okay. My things are all numbered wrong. All right, I gotta fix this. All right, I apologize. Okay, today is week 4, Monday, and we will cover tuples. I just made a change here. This says 3-3, but let me make this change again. Sorry. Slides. See if that makes a difference. There we go. I'll have to push this change in a minute here. So all right, and then you can get fetch and get merge, get fetch upstream, get merge upstream main, and that should get you the latest files here. Okay, but we'll take a look at tuples. We took a look at lists last week, and tuples are a lot like lists, except they are immutable. Right? That's kind of the biggest difference. So yeah, that's what this slide says. It says tuples are like lists in that they can contain objects of different types. Tuples are ordered and they preserve order. So like a list, you can put them in order, versus a dictionary, which is inherently unordered, and you find things in a dictionary by asking for the key. In a tuple in a list, you find things by asking for its position. You say, what's the 8th item? What's the index 0 item? Things like that. But the key difference is that tuples are immutable. You can't append to a tuple. You can't modify values in a tuple. And the difference is that when you create a tuple, you use parentheses. Okay, so you use parentheses and rather than the square bracket, okay, or a curved brace, right? It's also not required to use parentheses. And if you just create a whole bunch of stuff with commas here, Python will interpret this as instructions to create a tuple. So here, I don't have any kind of parentheses or square brackets or anything like this. And when I ask for what is t, it comes back and says, hey, this is a tuple. Okay, and we can tell it's a tuple because of the parentheses that appear, right? And of course, you can use parentheses as well, and that will create the tuple too. So, so both of these commands are equivalent. This one has parentheses. This one does not. Although, you know, my recommendation is that you do use the parentheses just so that it's a little bit easier to recognize as you're going back and reading your own code. Okay. You can also create a single tuple by having a tuple with one value by having a trailing comma. Okay. If you don't have a trailing comma, it doesn't work. All right. So here, tuple of one value, we put an A with a comma. This tells Python that this is a tuple and there's only one value here. Okay, we have an index 0 thing, put something, and if we ask, hey, what is this? It's going to come back and say it's a tuple. And what's the length? The length is 1. Okay, if you don't include the tuple, right? I mean, if you don't include that comma, you just put in parentheses and quote A, and it's a single value. Okay, Python doesn't understand that this should be a tuple. It's going to just see the contents and say, oh, that's a string, right? And it's going to see this and it's going to say this is a string, right? So there is a difference between this and the difference between this. This is a string. no comma, you put in a trailing comma, and then Python will understand that this is a tuple. Okay. Well, here, this is not a good example, but if I had ABC in here, and asked what's the length of the string, it would come back as 3. And if I had ABC in here with a comma, and I said what's the length of the length of the tuple is 1. You can also create empty tuples with the tuple function, parentheses, nothing inside, and that's going to create an empty tuple, you know, much like you would end up with an empty list or an empty dictionary if you use those functions like that, right? So you ask, make me a tuple like this, then you'll get empty tuple. Okay, and you can't just do parentheses like this. I think that confuses Python. If you just say T3 is equal to parentheses, that's confusing. You can also take other iterables, and iterables include strings, and you can put those into the function tuple, and it will take all of the elements of the iterable and turn it into a tuple. So here I've taken the string hello, and I've made a tuple out of it. Okay, you can take something like the range object, and I've made a tuple out of it. Or you good old-fashioned list, you put in a tuple, and it becomes a tuple. I mean, the list is easy, right? You just drop the square brackets and put parentheses on them, and they're equivalent. But these are things, you just throw them into the tuple, and boom. All of the indexing rules that apply to everything else, like lists and stuff, they also apply to tuples. So everything is 0 indexed. So if I say, hey, what is at the item at position 1, comes back and says it's a string apple, right? Index position 1. You can do slicing 2 through 5, so that's going to go from there to from there to there, from the 2nd comma to the 5th comma. So all of those kind of slicing rules and indexing things that we've covered also apply to tuples. So the key difference with a tuple, again, is that they cannot be modified. So I have basically the tuple and the list equivalent of each other. The tuple has the parentheses, the list has the square brackets. Okay, and I called the tuple T, I've called the list L. And so if you do something like this, you can say, hey, in the list, I want to assign the value 100 to list index position 0. And Python's happy to do that. You try to do something like that with a tuple, all right, trying to modify the value, right? You try to say, I want to assign the value 100 to the tuple index position 0, okay? And it comes back and says, tuple object does not support item assignment, okay? One thing I appreciate about Python is their error messages, I think, are very clear. Like you can be like, oh yeah, right? Just read the error message, right? It says a type error and the tuple does not support item assignment. Overall, you know, depending on the language, some error messages are completely cryptic. Python, generally the error messages are very helpful. Methods that modify a list in place, such as append, insert, pop, all of those kinds of methods that end up modifying the list, they don't work for tuples. So you try to do something like append the string X to the list, and the list it appends the value, no problem, okay? You try to do something like that to a tuple, it's going to just say the tuple has no attribute append, okay? No attribute, no method that allows you to do such a thing. So you can't modify elements in a tuple, but you can, like if you wanted to take the tuple and you wanted to just replace the first thing. So here's our, you know, the first element in the tuple. If we wanted to replace it with the number 0 with the character A, if we want to do something like that, what you would have to do is you'd have to create a new tuple by saying here I've got the tuple consisting of just the letter A, and then let's add on everything else from the rest of the tuple or something. So here we're just creating a whole brand new tuple. Okay, this is not a modification of the old tuple. We're just creating an entirely new one that just kind of copies over some of the elements. And there you go. And that's what you have to do. Yeah, it's kind of like if you wanted to create a string, you can't modify the elements of a string. You can't just say like in this string, I want to change the third character to the letter K. You have to just create a brand new string. Okay, so relational operators work with tuples and other sequences. And the way this works is Python compares the first element from each sequence. And if they're equal, then it goes to the next element. And if those are equal, it keeps going on to the next element until it finds elements that differ. And then when they're different, then it does a comparison operation. Okay. And then, and after that, the subsequent elements aren't even considered. Okay. It's kind of just like the way you would alphabetize words. You kind of look at the first letter, then you look at the next letter and the next letter. And then when there's a difference, you say, oh, okay, this one comes before, and therefore the entire word comes before the other word. And it doesn't matter all the letters that come afterwards, right? So here I've got the tuple 0, 1, 2. Is that less than 0, 3, 4? And this is true. The 0 is tied, but the 1 is less than the 3. And that's the only thing that matters here, okay? So here I've got 0, 1, and I don't know, 2 million. I got 0, 3, 4. And again, the zeros are tied, but then it compares the 1 to the 3. 1 is less than 3, and therefore it comes before. All right, and it doesn't matter that this is 2 million and this is 4. This doesn't even factor into the decision making. This is a 1, this is a 3. The 1 is less than the 3. Here I've got 0, 500, 2. Is that less than 0, 3, 4? Now the 500 is greater than the 3, so it comes back false. And here I've got the letters ABC, ABCD. ABC comes before ABCD if we were to kind of alphabetize these. So I just made it, if you had the string A, B, 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 ABC, ABCD, it would be alphabetized in this order. And therefore, because this comes before the other in alphabetical order, this is denoted as being less than. So those are comparison operators. I think that's so far so good. Let me go ahead and give you your first view quiz answer for today. The first view quiz answer is the letter B. B as in bear. B as in bear is your first view quiz answer. A useful tuple idiom. So we have these like little, I don't know what you would call them. In programming languages, you develop these kind of programming idioms. And so one is that you can actually switch values with a tuple, which is quite convenient, because if you did not have something like this, you need to employ kind of a temporary value. So let's say you have A equal to 5 and B equal to 1, and you wanted to swap the values of A and B. You want B equal to 5 and A equal to 1. Could you do this? Yes, you could do this. But if you can only do kind of assignment one at a time, you have to use a temporary holder. Otherwise, what would happen? If I said, take the value 1 and assign it to A, and take the value in A and assign it to B, when I use the 1 and overwrite A, that value of 5, has been lost. So I would have to first temporarily store A into a variable called temp or something. Then I can assign the value B to A, and then I can take that value temporary and assign it back to B. And then I've swapped the values. A is 1 and B is 5. That's exactly what I wanted to do. And that's fine. This is completely valid. It works. No problem. Okay. But we have a slight slightly faster shortcut. All right, so here I have A equal to 5, B equal to 1. And if I want to swap those values, I can take the tuple A comma B and assign it to the tuple B comma A. And if I do that, then the value that used to be in A will now be in B. So B now has the value 5. And the value in B, which used to be 1, now gets assigned to A. And so when I print out A and B, A now has the value 1 and B has the value 5. Okay, so we're just kind of, so Python processes this entire statement all at once, and it kind of just, it takes this tuple and it unpacks it into this tuple, which is which I think is nice. Okay. We've seen this before when dealing with a function, and we can take what a function returns and unpack them into elements of a tuple. Okay, so here is the function string split. Okay, so there's the function string.split, and right now the address is this string, which is my email address, and we can say, you know what, I want to split this string on the symbol, the @ symbol, right? Which is really the only, you ask like, well, is there a format for email addresses? And truly it's just something at something, okay? You can try to do like, oh, you need to have this many letters, dot, and it's got to be .com or .whatever, but there's so many things now, like all of these weird domains, right? You have like .cloud and .info and .me and all of these things that don't even bother. Just say, is there an @ sign? And if there's an @ sign, then it could be an email address, okay? Is there an @ sign? And the @ sign is not the first, it's not the first or the last character in the string. Could be an email address. It's too hard to tell. So, well, anyway, so here the string is called ADDR. So we're going to do ADDR.split on the A, the @ sign, and it splits it. All right, and normally it returns a list. All right, what I can do is I can just say, hey, you know what? Take this result. We're starting this entire line fresh again, and we're going to just take this and unpack the results into username and domain. And there you go. And you'll see this frequently when reading other people's Python code, okay? Because this is such a useful feature, is that if you know you're anticipating this many items in the output, it's often useful to have each of those items assigned to a variable or some kind of object name that you can refer to later, right? And so when you do this, you can then refer to each thing. You can say, hey, what was the username? It was that. What's the domain? It's that, okay? And so that's a very useful thing to use with tuples, tuple unpacking. Truly a great feature of Python. And so, we saw this when we were talking about functions again. So here I've made up this division function where we're going to divide x by y, and we have the integer portion and the remainder, right? So if you do say like, what's 17 divided by 4, you would get 4 remainder 1, okay? And so the integer portion would be 4 and the remainder would be 1, something like that, okay? You have the floor division and the mod operator combined. So here I've got 23 comma 5, and because this function is returning 2 values, the integer and the remainder, we can unpack those and assign them to A and B. So the integer here, 23 over 5, the integer portion will be 4, the remainder portion will be 3. And we can ask them what's A and B, and indeed we get 4 and 3. Right? And that's actually exactly what the internal function, the built-in function that Python comes with, div mod, modular division, is 23 comma 5, indeed returns this exact tuple, 4 comma 3. So there's only 2 methods that you can really do with a tuple, right? Lists lists had so many methods. You could do like list.sort, list.append, list.pop, all of those things. And those were all methods that ended up modifying a list. Okay, obviously with a tuple, we cannot modify things. And so we've got tuple.index and tuple.count. Okay, some of you might wonder, like, what's so special about a tuple? Like isn't it just a list and we can't change it? Like, isn't it easier just to have a list? And sometimes it's useful to know that that the thing you're dealing with cannot be changed. Okay, it's kind of like the difference between writing with a pencil and writing with a pen. Okay, and when you have a pencil, you can go back and erase it and make changes. And there are lots of times where using a pencil is great. Okay, but sometimes, like if you're going to sign a document, you want to make sure you use a pen. Okay, and there's going to be certain situations where you don't want to have to worry about something later on trying to change the value of your tuple. Okay, that once you assign the values to the tuple, you don't have to worry about the tuple changing up on you. Okay, and so there are certain instances where this is important, and one of them is especially when you're using keys in a dictionary. Okay, keys in a dictionary, you don't want those changing up on you, and we'll take a look at that later. But before we get there, let's talk about these tuple methods. So tuple.index is exactly just like the index function with a list, right? So you say, hey, what is the index of the item dog in this tuple, right? And the index position is index position 4, right? It's the 5th item, index position 4. Count how many times does the item 5 appear in the tuple, right? These work exactly the same way they did with a list, okay? Because both of these are kind of just like, can you give me some information about the tuple? I don't need you to change anything. I don't want anything to change. I just need a bit of information from the tuple. These functions can be used with basically any kind of iterable. They can be used with a tuple. They can be used with a list, a string, a dictionary. You can ask, what's the length, all right? And if you've got numeric values inside, you can ask for the sum. You can take the thing and you can have a sorted version of it, a sorted copy. Okay, it doesn't actually sort the thing, but it gives you a copy of it that's sorted. Okay, you can ask what's the minimum or what's the maximum value inside there. Okay, so here's just some arbitrary digits in a tuple. Here is a list of words. Okay, I can ask what's the length of this tuple, and I'll say, oh, you got 7 digits in there. Okay, what's the sum? They're all numbers, so it has no problem adding them up. Okay, if you say, hey, what's the sum of this? Okay, then Python says, what are you doing, right? You're trying to add these two together. That's just not going to work. Okay. You can ask for a sorted version of the tuple. The sorted version of the tuple gives you back a list. Okay, it gives you a sorted copy, but it's also the object returned is a list. Okay, you can take the and just to show that the original tuple is unchanged, I've done print some digits, and the original tuple is indeed unchanged. It's still a tuple. You can apply it to the list or any kind of set of strings, and it will sort them alphabetically. You can ask what's the minimum or the max. The min will be the first value if you sort them. The max will be the last value if you sort them. Okay, will be last value, last item that comes alphabetically, if there's strings. Okay, here's a dictionary. Dictionary number means the keys are numbers. So 1 corresponds to the string character A, 2 corresponds to B. And then here I've got dictionary alpha, which means the keys are letters. Okay, so A corresponds to 1. So these are similar dictionaries, but one is kind of the inverse of the other. One, the keys are numbers versus the keys are letters. Okay. if you ask how many letters, I mean, how many items are there, it's going to see there it's a length 3 dictionary. Sort them. If you say, give me the dictionary sorted, it's going to give you the keys in sorted order. Okay, it's going to take the keys and just return the sorted keys. Okay, same thing with it just returns the sorted keys here. And what is the largest key value would be the max, applying these functions to dictionaries here. Okay, let me go ahead and give you your second view quiz answer. Second view quiz answer is B. B as in bear. B as in bear is your second view quiz answer. If you use math operators with lists, tuples, and strings, we've seen this already with strings where we did kind of like hello times 2 and hello plus goodbye or something, and it kind of pastes those together. They actually work the same way with lists and tuples. So multiplication will duplicate things and addition will append things. And the behavior is the same. So if I take these two lists, A, B, C, and D, E, F, and I say, hey, let's take the list and multiply it by 2, it's going to go A, B, C, right? Much like if I were to take the string, and if I said take the string and multiply it by 2, we would basically get the string equivalent of this. But now it's happening with a list. If I say take list 1 and list 2 and add them together, it's just going to kind of append these two things together. It's going to append lists 2, D, E, F, to list 1, A, B, C, and expands that. Okay, same thing with the tuples. Multiplication does duplicates it. Addition appends the things. If you try to add a list in a tuple, you can't do that. It complains and it says you can't, can only concatenate a list to a list or something. So you can take the tuple and convert it to a list and append them, or you could do the opposite, convert the list to a tuple and append them, because you can append tuples together, and this will create a brand new, entirely new tuple. Okay, so here is a really nice thing that that you can do with Python, and this is variable length arguments. So sometimes in Python, you'll have a function, and the function will accept as an argument some iterable object that it will iterate over, which allows you to have an arbitrary length object going into the function. All right, so what do I mean by this? Okay, let's say I'm going to define a function called print all of some arguments, and we're just going to, all this is going to do is it's just going to print the arguments that come in. Okay, we're just going to ask it to print all the arguments that come in. Print by itself, I think, already will handle a multiple length thing. So anyway, I'm going to call print all, and I give it 4 things. I give it 1, 3.05, and high, right? And Python gets upset. It says, you're only supposed to give me 1 argument, and you gave me 4, right? It says it takes 1 positional argument, but you gave me 4, so I don't like this. Okay, so the only difference between this function definition, I'm going to redefine the function. I'm going to put in a star here, star args, okay? And basically you just do a parameter name that begins with a star. We'll take whatever comes in here, and it gathers all of those things into a tuple, right? So now, how does this work? these values, 1, 3, 5 high, they get gathered into a tuple. And so now when I say print the arguments, it comes in as a tuple. So it gathers them into a single tuple object that we can then work with. Okay, so say again, I'm providing it 4 separate arguments, and it's going to gather them into a tuple. This is basically the equivalent of adding an extra parentheses before the 1 and an extra parentheses after high, and that would have gathered them into a tuple and do this. Okay, but the star args will kind of automatically do that for us. So let me just show you how this might work. Okay, so here I'm going to try something. We'll take this and we'll just make this just a touch more complicated. And we're defining a function called print lines. Okay, and it's going to take a bunch of stuff, gather them into a tuple. And then what do? We're going to iterate over that tuple. We're going to say for each element in that tuple of arguments, print each element. Okay, so no surprise here. All right, so here we're going to say print lines, and then I've just done hi, comma, goodbye. And then it prints out hi, and then it prints out goodbye. It gathers this into a single tuple, and then it iterates over each one. So it does, the first element is hi, it prints that out, then it goes to the next element in the tuple, goodbye, and it does that. Okay, or here is just a bunch of numbers here, and indeed it gathers them into a tuple and iterates over each thing. Okay, and that's it. All right, it basically simplifies calling of the function so that you don't have to gather them into a tuple yourself, and it will kind of put it into a tuple and then allow you to kind of work with that structure. The opposite is so gather. A star will gather elements into a tuple when they're going into as arguments. And then there's the complementary function called scatter, or the complementary concept of scattering, which says, let's say the values that come back as a tuple, and you want to break them up. Okay, and you can. I'm sorry. Yeah, let's say you have a function that takes 2 arguments, but you want to pass it a tuple. You can use a star, and it will scatter the elements here. Okay, so here, remember, the divide function takes in 2 arguments, x and y. Okay, so the star is kind of like a tuple toggle. Okay, a tuple toggle. So here, let's say I have this tuple 23, 5, and I want to run my divide on 23 and 5. Now, if I put this straight into the divide function, it complains because the 23, 5 goes into position x, right? This is one object. This one object goes into position x, and it complains, and it's saying, I'm expecting 2 arguments, all right? And you gave me just 1. You gave me 1 argument with a tuple, 23, 5. What we want is x to be 23 and y to be 5. But if we call this on this, it doesn't work this way. So what do? We use the star, and it kind of takes off. It scatters the elements in the tuple, and then it assigns the 23 to the x, it assigns the 5 to the y, and then the function operates, and we get a 4, 3. So the star kind of like toggles the tuple on or off, right? So when the elements come in not as a tuple, you put the star there, it will turn them into a tuple, and you can operate on it. If the elements do come in as a tuple, you can put star on the tuple, and it will break them up and scatter them appropriately. So it's kind of a nice handy feature here. We've seen the zip function briefly before when we were creating dictionaries, and let me just show you a little bit how more examples of the zip function. Okay, these are like Pythonic features that You know, maybe other languages have something similar, but I think they're implemented quite nicely in Python, right? So a zip will take two iterables or two sequences and basically zips them together, right? You get this kind of this interleaved thing, right? Just like a zipper. So here I've got a string ABC. I've got a tuple 0, 1, 2, and we're going to zip them together. I'm going to zip S and T together. And it comes back and says, all right, I made this zip object, which in of itself often probably not as useful. Sometimes you want to work with the zip object directly. If you want to see it, we can just say, hey, iterate over this zip object and print whatever it is, right? So the zip object consists of 3 elements, okay? And we're going to say for each element or each pair in the zip, print that out. And what it is it's an iterable that consists of basically these tuples of length 2, where we have paired each kind of object, the A with the 0, the B with the 1, and the C with the 2. We've got a question in the chat. What if the number of elements are not the same? I got an example that shows that, okay? All right, so so a zip object is a kind of iterator, which is any object that iterates through a sequence. Iterators are similar to lists, but unlike lists, you can't use an index to select an item from an iterator. So you can't say like, give me the third item in a zip, okay? But what you can do is you can put the zip object inside a list, and then it will process the entire zip object, okay? So one thing is that if, let's say you have this really long, these 2 really long sequences, like millions of items long, okay? When you create the zip, it basically creates instructions in memory. This zip object is like almost like instructions. You don't actually have to process through all million things, right? And it's just as you're iterating over it, it's going to say, okay, and it's going to kind of return these things like just in time on the fly. It's going to kind of process the A, the B, the C, the D, as long as you're asking for all of these things. If you take this zip object and you throw it inside a list, then in order to create the list, all right, so here I've taken the same zip object, zip S and T together, and then we put it inside the list. And so in order to create this list, your computer has to process all of the elements in the zip object, and then it puts it inside the list. So, this requires a little bit more processing power up front. Okay. If you run type on a zip object, what will it return? It'll say it's a zip object. It'll basically say it's a zip. Okay. A zip are basically instructions to interleave things together, but it doesn't actually require the computer to process all of that interleaving all at once, right? It's kind of just like, when you ask for it, I'll do it. But until you ask for it, I'm not going to do it. When you take the zip and you throw it into the list, then it's saying, oh, you're asking for everything, I will do it. And it will, it process the entire zip object. Okay. And if it's 3 elements, it's going to take like 1 microsecond. Okay. It's going to be like 2 clock cycles. It's not a big deal. But again, if you got like a billion things, all right, this could be an issue. Okay. So what happens if they're not the same length? Then it just throws everything else out that's longer, right? It gives you it pairs up everything it can. It doesn't do recycling. It just pairs up everything it can and says, oh, all right, we ran out of this stack. We're going to throw out the other stuff, okay? So remember, you can do any kind of iterable, right? So here are strings, ANNE, 4 letters, ELK, 3 letters. It's going to pair them up. A with the E, N with the L, N with the K, and this extra E gets thrown out. All right, so you have the zip object, okay? So here's this zip object, or the list of tuples effectively. And so if we have something like this, okay, so here is a bunch of stuff, a list of tuples, you can go iterate over them and unpack them as you iterate, right? So you can say for each element, right? So this, I have T, but it's actually a list. This list is a list of length 3, and every element in there is a tuple, and we can take that tuple and unpack it into a letter and a number. And then we can ask, print out the number, print out the letter. And it will, and so here we've unpacked the A to letter, we've unpacked the 0 to number, and then we can do whatever we want with it. Right. And so this is kind of iterating over a bunch of tuples. So here is, here's like a little snippet of code. All right, it's going to traverse 2 iterables, right? So whether it's strings, lists, tuples, whatever it is, it's going to kind of go element wise. It's going to compare the first with the first, second with the second, third with the third. And it's going to ask, is there a match? Is there a match? Does the 4th element match with 4th element? Does the 8th element match with the 8th element, right? So what we're going to do is we're going to take one iterable and another iterable. We're going to zip those 2 together. And then for everything in this zipped thing, we're going to unpack it to X and Y. And we're going to iterate over the whole thing, or maybe not the whole thing. We're going to iterate until this either returns true, or we get through the whole thing and we haven't returned true, and then we would return false. So we're going to just iterate through each kind of pair. We unpack it to X and Y. We ask, is X and Y, are they the same? And if ever that is true, we return true. Anytime you hit return in a function, the function quits, right? So if this is ever true, we return true and the function quits. If we get through this entire thing, the entire for loop without returning true, then the function returns false. All right. So we ask, is there a match between A and D? Nope. B and E? Nope. C and F? Okay, none of those things ever came true, so the function returns false. Okay, all right, here, what about A versus D? Nope. B versus E? Nope. C versus C? Yes, that's a match. So the function returns true. And so you can do, whatever you want. Here I've got A, B, C, D, D, C, B, A. And again, it's going element wise. So it compares the A to the D, the B to the C to the B, and the D to the A. There's no match there, right? And so it's just a tiny little code snippet that iterates over a zip object, okay? And again, the reason why I put the zip here, rather than processing the entire list, rather than throwing this into a list, is because let's say, again, this tuple, these sequences are like 1,000,000 things, okay? 1,000,000 things long. You don't actually have to match up all 1,000,000 things, right? You just go element by element by element, and let's say you find a match at the 4th thing. You can just stop right there, right? Yeah, as soon as you find a match at the 4th, you can just say, oh, my work is done, okay? It doesn't matter what happens to elements 5 and to 1,000,000. Okay, you saved yourself 999,995 comparisons. So, so again, Python is kind of lazy in this aspect, in that it's not going to process anything that it doesn't need to until you ask for it. If we said, hey, I want the entire list now, then it will do that entire thing. Will zip only work with 2 tuples, or can you match more than that? You know what? Let me just double check. Okay, let's so let's try zip with ABCD, and let's do a tuple 1, 2, 3, 4, and I think this works. Add this to X. All right, and then let's do X. Yeah, so it will. You can do a string with a tuple or anything like that. So basically, just any 2 iterables, it will go through and match them up, right? So here, let's see, we wanted to do something. I don't know. What do you want to see here? Okay. that into a thing, and it goes through each element and does that. So you just need two things that iterate over, right? Oh, can you match more than that? Oh, like 3 things? I don't think you can do 3. You can't zip 3 things together. Let me just double check. But if I try to do like range 4. Oh, maybe it worked. Maybe it works. Oh, look at that. I've never done this before. All right. Well, we discovered something fun today. All right. So yeah, you can zip a bunch of things. Oh, this is exciting. All right. It gives me a zip object, and yeah, it just takes each thing, zips them together into a tuple. So now I got tuples of length 3. Oh my goodness, the possibilities are endless now, right? Okay, so you can just zip. Apparently, you can zip an arbitrary bunch of things. Oh, let's try this out. Okay, A, B, C, D. Hello, goodbye, next, last. Range 4. What else do we want to do? I don't even know. Okay. 7, 8, 9, and 0. Okay, let's do that. And then that out. It's going to be, yeah, look at that. Okay. All right. So it does we want what we want it to do. Okay, great. Even better. Enumerate. Enumerate is basically like a zip, except one of the things is a range of the length that you want, right? So this is just like a shorthand for zipping something together, right? So here I'm going to do morning, enumerate morning, and it's like I've zipped morning with the range 0 through 6. Okay, so enumerate is kind of like zipping a range object with the iterable. So it's going to go, it's like a range 7, right? So we got morning is length 7 and goes range 7, and it iterates 0 through 6 there, right? So here is A, B, C, D, and I say enumerate, and it's going to 0, 1, 2, 3 for that. Okay, so enumerate's just a little shorthand. It's the same thing as doing zip range 4 on this, and it gives you back basically the same results. So enumerate's just a shortcut of this. All right, let's take a look at dictionaries. I got just a couple minutes left here. All right, so if you do dictionary.items, okay, so we talked about the view object, the .items view object. It iterates over this. I mean, it gives you back basically a sequence of tuples of keys and items, keys and values. Oh, let me give you your last view quiz answer. Last view quiz answer is D. D as in dog. D as in dog, D as in dictionary. Last view quiz answer for today. So we get a sequence of tuples. And again, just like any other iterable of tuples, you can unpack them and you can iterate over them. So you have a key, comma, value. You can unpack those and do whatever you need to inside your code here. You can take you can make a dictionary out of an enumerate thing, and it will basically zip EFG with 0, 1, 2, and then turn all of those 0, 1, 2s into keys, right? So you've got a dictionary here. If you wanted to swap the keys and elements in a dictionary, you can do this. And as long as the keys are unique, it'll be fine. And if the keys aren't unique, then it basically will update the earlier elements as you're iterating through this. So here we're unpacking the key and the value, and then we're gonna, in our new swapped dictionary, we're gonna assign the value as the key and the key as the value, and that will end up swapping 0, 0, 1, 2 with into the values there. Okay, again, we can create dictionaries out of sequence of tuples. you can, so here are alternative ways, right? So here's a sequence of tuples. I think we showed you this when we were creating dictionaries. We can also just zip XYZ with these values, and then we can create a dictionary out of that, right? So one useful application of this, and I'm sorry, I'm going a minute over here, is let's say you have this complicated function, right? So again, the keys in a dictionary, you cannot use lists as a key in a dictionary, but you can use a tuple. And so here's an example. Let's say you have this complicated function where it's a two-dimensional function, and the thing that comes in is you need two arguments, right? So let's say you're going to calculate some function where you need an x value and you need a y value, okay? And here it's a very simple function, x squared plus 2y. But this part could be something very complicated, where it's like if you put in, 50 and 17, maybe it takes like 10 seconds to compute this number, right? You can imagine some kind of computation that requires a whole bunch of many iterations, and each calculation takes a few seconds to do, right? And in that case, it could be useful to actually store the values that you've calculated. So here I'm going to create a dictionary of basically known solutions. And we're going to use kind of the input values, 0, 0 as the key, and then the value that it returns will be the value. And so we're going to create a function called f, and what this will do is it will create a tuple out of the arguments that come in, tuple out of the arguments x and y. And if t exists in the dictionary known, right? So there's a dictionary of known values. If it finds it in there, it's going to say values already exist in the dictionary, and it's going to just look that value up using the dictionary hash lookup, okay? Otherwise, it will say the value has to be calculated, and it'll go through and calculate this. And again, this is a very simple thing, so it's not a big deal, but you can imagine a function that's very time consuming. And then once it calculates it, it's going to store that value into the dictionary, and it will return this result. Okay. And so here's an example where we're going to do 0, 0, 0 is already in the known dictionary. So it's going to just look that up. And here's something where we compute it 1, 2, and it has to calculate it, and it has 5, and it stores it into the dictionary. And so when I ask for 1, 2 later on, it's going to say this value already exists in the dictionary, and it returns it, okay? And if we ask what's in the known dictionary, it has two things in there. Okay, that's it for today. Thanks for sticking around. We'll end here, and we will see you guys on Wednesday.